Hello everyone, welcome to my channel. I'm Kinzaza. My registration number is 21TE03, and on this channel we will explore various topics related to signal processing, coding and everything in between. In today's lab, we will be covering the fundamentals of digital signal processing, and we will focus on the basic logic of signals and creating and calling functions. So let's begin with our task number 1. So in the first task, we were asked to plot the signal sine 2 pi ft. So the first line of the code creates a time vector t ranging from 0 to 1 with a step size of 0.01. The next line f is equal to 1 indicates the frequency of the sinusoidal signal as 1 Hz. The third line is the signal which we want to plot. Since the signal is in the continuous domain, so we will use the plot command to plot the sinusoidal signal, and the output will be like this. So moving towards our next code, this signal is very similar to the previous one. Firstly, we have set the time vector ranging from 0 to 1 with a step size of 0.01. Then we have set the frequency. Then we have mentioned the signal which we want to plot. Then we have used the plot command to plot the signal. And some changes are made here, which are title, X label, Y label, and axis. We have added a title to our graph, and the title is plot of sine wave of 1 Hz. We have set X label, Y label, and the axis. So I'll show you its output. Its output will be like this. It's the same wave as predicted in the previous task, but here I have added the title like this: plot of sine wave of 1 Hz, and x-axis is labeled as time in seconds, and the y-axis is labeled as amplitude. And here I have mentioned the axis. X-axis are ranging from minus 0.5 to 1.5, and y-axis is ranging from minus 1.5 to plus 1.5. Moving towards our next task. In this task, we were asked to plot two signals using the same plot command and in the same graph. So firstly, this time vector ranges from 0 to 10 with a step size of 0.01. Then I have set the frequency of the first signal as 10 Hz and the frequency of the second signal as 520 Hz. So this is my signal 1, which is a sinusoidal sine wave, sine 2 pi ft, and this is my second signal. I have used a single plot command to plot both the signals. Since both the signals are in the continuous domain, so I have used the plot function. Nextly, I have added title, X label, Y label, and axis. The title is plotting multiple signals in the same figure. Okay, I'll show you its output. Its output will be like this. X-axis are ranging from 0 to 1 and y-axis is ranging from minus 1 to 1 as mentioned in the code. Also, x-axis is labeled as time in seconds and y-axis is labeled as amplitude. And I have set the title plotting multiple signals in the same figure. We are observing two signals. The one is with red color and the second one is with blue color. So the one with red lines is a signal 1 and the other in blue is signal 2. Moving towards the next task. This is exactly the same code as discussed in the last slide. Okay, wait a minute. The only difference in this MATLAB code from the previous one is that here we will observe the output in the form of dots. Also, the dots will not be connected with each other. So all the signal is same. We have set the frequency of the signal 1 as 10 Hz and the frequency of signal 2 as 520 Hz. But we will observe output in the form of dots. Like this. I hope that you have heard the sound of beep here, which is mentioned in the code. This command sound signal to 16,000. Place the second signal as sound with the sample rate of 16,000 Hz. Moving towards the next code. In this MATLAB code, we were asked to find the mean of random variable. So the first line n is equal to 50 sets the variable n to 50, indicating that we want to generate 50 random values. The next line r is equal to random n1. This line generates an n by 1 vector r of random values drawn from a uniform distribution between 0 and 1. Each element in the vector represents a random data point. Here I have used command plot r. This line creates a plot of random data stored in the vector r here. Next is m is equal to mean of r. This command is used to find the mean of the random variables. The next command hold on allows multiple plots to be added to the same figure without overwriting the existing plots. The next command plot 0n to nm adds a horizontal line to the plot, and the line is drawn from the point 0m to the point nm. The next command hold off turns off the hold state, indicating that the subsequent plots will replace the current plot. And finally, I've added a title for my convenience. I'll show you its output like this. Okay. Moving towards my next code. In this code, I was asked to find the minimum value from a given range of random values. So simply I have taken some array of random numbers like this, and I have stored it in a variable x here. Then I've created a new variable q, and here I will find the minimum value from x, and finally I'll display the result. So the result displayed will be 1. In the similar way, we can find the maximum value. And now in order to find the average, I have created a range of numbers here, and I've represented it by variable x, and then I've created a variable average, and here I'll find average of my random variables and display the result here. So the average will be 5. In a similar way, I can also reverse my array like this. Okay. Moving towards my next code. In this code, the first line creates a time vector ranging from 0 to 0.5 with a step size of 0.01. The next line, x is equal to random 51, generates a column vector of x with 50 random values drawn from a uniform distribution between 0 and 1. The next line, y is equal to sine 10 to pi t, generates a sinusoidal signal y with a frequency of 10 Hz. Sample at the time points defined by the vector t. Subplot 1 to 1. This line creates the first plot in a 1 by 2 grid and selects the first subplot for plotting. Similarly, the next command creates the second subplot in 1 by 2 grid and selects the second plot for plotting the sinusoidal signal y. The output will be like this. This is my first subplot and this is my second subplot. Okay, moving towards the last task. In this task, we were asked to make a function with the name win4 that displays 4 plotting windows in the same figure. Okay, so the first line, function win4. This line declares a MATLAB function named win4. The function takes no input arguments, therefore I have put empty brackets, empty parentheses here. The next command, subplot 2 to 1. This line creates the first subplot in 2 by 2 grid and selects it for plotting. Similarly, the next, subplot 2 to 2. This line creates the second subplot in the same 2 by 2 grid and selects it for plotting. Similarly, the next line creates the third subplot in the same 2 by 2 grid and selects it for plotting. And the last one will create the fourth subplot in the same 2 by 2 grid and select it for plotting. And here my function ends. So let us observe its output. Its output will be like this. This is my first subplot, this is second one, this is third, and this is last and final one. So we have completed our lab task. Thank you for watching my video. Please like, share and subscribe. Thank you.